All right, so here, let me ask you this. If something has 8 valence electrons, can you add more to it?
No.
You can't. You can't add 8 to something that already has 8. But you can't add to something that already has 8. Which elements on the periodic table already have 8 valence electrons? Yeah. The noble gases. Okay? The noble gases are already stable. They do not need to bond. So we do not use them for this. Okay? Now, what we're looking for is we're looking for a metal-non-metal combination that when it added together gives us 8 valence electrons. That's what makes a stable compound. Okay? What did you come up with? We're going to list them all. Okay? Before we do so, however, switch your paper with somebody at a different table. And
Isabella.
I'm going to give you guys red pens. You're going to mark on their papers.
Oh, but I take pride in my
And then I'm going to collect
Okay,
them.
Isabella, I won't do much more. Oh.
Here.
I mean, they're organized. They're just not. Like, you don't have color.
Okay?
I'll still trade with you.
The thing you just did. Isabella, I'll keep them nice and neat. I'll write it.
They're organized, they just don't have a lot of color.
Isabella, I'll write it in pen.
Yes?
I'll write it in
extra pen.
I just pen.
That's fine. I'll collect it back in a minute.
They didn't write down like.
If there's anything like that.
They didn't have to.
Isabella, they're completely wrong on my
They didn't have
but
to.
I'll just make clear.
All right, so here we go. You have a list of compounds. I do not want you to say whose paper you have. I don't want to know whose it is.
Cinderella.
Okay? What I do want, though, is you to tell me which compounds they came up with. Okay? So, Parker, tell me, which compound did you have?
H and F.
H and F.
Nitrogen and fluoride.
Okay, now, if we're looking at the periodic table, or that table back there, is H a metal?
No.
No.
Not a metal. So that would not be an ionically bonded substance.
I thought it.
So just put a cross through it. No, just don't worry about it. This is a learning experience to help us identify which ones are correct and which ones are not. Okay? All the red substances on the periodic table are non-metals. So we can't use H even though it's on the left. It has to be metal, non-metal, and add up to 8. It has to be both of those things. Okay? What other kinds of substances might we have? Emma.
OCA.
OCA. Okay, I agree that both of those things can be
I don't know
used,
what it
but
is.
which one gets listed first? Metals come first. That was when your notes. I did lots of examples, and I had you write M, N, M. Metals always came first. So CaO would be a proper substance. So if you have that one, put a check next to it. All right, what other ones do we have? Yeah, Gloria.
R-E-S-E.
R, which one?
Maybe R-A.
Maybe R-A or R-B. We'll go with R-A. R-A-S-E. Now, S-E,
There's an R-E.
S-E is barely okay because it's a metalloid. It counts. So yeah, that would be a great one. Rusty. Actually, radium selenium.
Is there an R-E? Yeah, there's an R-E.
Where is R?
In the transition metal.
Ah, we're not going to use transition metals. I think it's what? Rhenium. Bo Behrman.
CSI.
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 Cesium iodide. Yes, that would be a proper substance. You have your metal, your non-metal, and they add up to 8. Grace.
If they don't have the same exact one, is that bad?
No, we're going to come up with over 30 of these.
Okay, I have one.
Yeah.
M-Y-S.
MgS.
Oh, MGS, sorry.
MgS, magnesium sulfide. Yes, that would be an ionic substance. You have metal, non-metal. Magnesium has 2. Sulfur, 6. They add up to 8. Emma.
Check by it.
Li2S.
Li2S. Ooh, that's very good. Yes. Li2S. Here's where that one comes in. They're saying 2 lithiums. Lithium has 1, so if you have 2 of them, you have 2. S has 6. 2 plus 6 is 8. So that would also be metal, non-metal, and 8 valence electrons. That works. It fits my criteria. Okay, Miss Alon.
FR2 oxygen.
FR2O, francium oxide. Yeah, that would work. FR2O. Yeah, very good. Parker.
LiO.
Lithium chloride. Yeah. Yeah, LiCl. Notice that the first letters of an element are always capitalized. If it does have a second letter, it's lowercase. Then capital, lowercase. So we see Ra, radium, Se, selenium. Okay, so we can kind of help to
Why is the
lithium
L in
chloride.
Why is the L in chloride
So it doesn't look like one.
like loopy?
So you know it's an L and it doesn't look like an I.
But it looks like an E then.
No, it's actually technically a cursive L.
What if there's
Well, I
a number
know
in
that.
between it?
If there's a number, then that number applies to the first one. So Li, 2 lithiums attached to a sulfur. Yeah? Reagan.
Okay, MGO.
MgO!
And then also, if they didn't capitalize the letters, like it was all lowercase, that is wrong.
You really should make a note to them because that will cause them a lot of heartache later on. Okay, so just make a note, maybe put little dashes underneath the front letters, just say capitalize these. Okay, if we don't capitalize, I can guarantee it will cause you a lot of trouble later on. It's good to get in that habit now before you get to high school and you have chemistry. I'm not going to mark him down for that, but I really do want that to be a focus. We want to learn how to write these properly. Okay? Yeah, Gloria.
For like beryllium and that column, I thought you wrote it as lowercase.
You always write the second letter lowercase, but the first one is always capitalized in any element on the periodic table. Mm-hmm. I don't think so. No, because here's why. Okay, I'll give you an example of why you have to have a capital first letter. Let's say that I wanted to write a couple of elements, and so I chose, let me pick one here.
Oh, because it could look like it's part of a different one then?
Yeah, let's say L-I-F. But instead of lowercase, I do L-I-F.
That could look like
Well, this looks like lithium fluoride. This looks like a lithium iodine and fluorine. Well, that doesn't work.
Oh, you can just
Okay.
put the first letter and it would still be.
So you only capitalize the first letter of each element.
Or
All
no,
right.
but how would you know it was lithium if you just put L?
You wouldn't. Okay? But what I'm saying is, what if somebody went L, capital I, instead of capital L, lowercase I? This is entirely different than this.
But how would you know it was lithium iodine?
You wouldn't. You would have to find something that was L, which I guess in this, I guess you're right. There isn't one, so it wouldn't work. That's why it's so important to capitalize the first and lowercase the second. Or in the case of lithium chloride, capital L, lowercase I, capital C, lowercase F. But let's get back to our list here. Gloria. KCl. Yeah, potassium chloride. That's a salt that our body needs. Miss Lixon.
CLFR.
Cl what?
FR.
Okay, make sure we're naming the metal first, but yes, those two things do go together. We're going to go FrCl, francium chloride. Metal first, then non-metal. Okay, Emma.
PSR.
PS.
It's capital P, lowercase s, lowercase r.
That couldn't work. That's one sentence.
PS is not in the first two columns, so pick a different one on that sheet.
BEO.
BeO, that works, beryllium oxide. BeO, not to be confused with BO, which is why we wear deodorant, okay? Yes,
KI.
Ki, potassium iodide. Ki, both capital because there are no second letters in K, potassium, or I, iodine. Parker.
It says MG. What's this? This looks like an S.
MgS, yeah, Mg, magnesium sulfide, that works. Actually, we already had it right here.
Isn't it like in foods?
Okay, Connor.
I think that's GMO.
CaSe.
Ca is our metal. Se is selenium. Okay? This is 2, this is 6. When added together, comes up with 8. Yeah, Gabby.
RBCL.
Rb, rubidium. Okay? First column of the periodic table. Cl, halogen, has 7. Yeah, that works. That's great. Connor.
FRI.
Fri, francium iodide. Sure, that's a good one. Savannah. RBB, yeah, RBBR. That's kind of a cool one, actually. RBBR. RBBR.
What's RB?
Rubidium bromine. So it would be rubidium bromide. Really? That's actually kind of a cool one. The RBBR.
Good job,
Okay? A lot of fun.
Doctor tried to call me.
But say what? Okay, you cannot have the non-metal name first. So switch it. Just put a little arrow. They have to switch them. You have to have your metal first, non-metal. Reagan.
RBCL.
RBCL, rubidium chloride, which is right here.
Wait, so transition metals can't.
Transition metals do factor in here. However, transition metals have a whole slew of their own rules, which we have to follow. Rules which we're not ready to tackle yet. And as a matter of fact, when you get to high school chemistry, you will see the rules that transition metals have, because transition metals do weird things. That's why we call them transition. So for our sake, right now, we're keeping it simple. We're just using the first two columns and the non-metals. And then if you get this down by the time you get to high school, then you'll be ready for the transition metal rules at that point. Okay? Because there's a whole slew of them and how to write them and whatnot. Connor.
BASE.
Barium SE selenide. Yeah, that would work. BASE. Okay? So if you have BASE, check it off. Gabby.
Base.
FRBR.
FRBR.
Should we write these down?
If you have them on your sheet, put a check next to them. Otherwise, raise your hand to submit yours. Miss Lalonde.
CSBR.
CS, cesium, BR, bromine. Yeah. CSBR, cesium bromide. Gabby.
SRO.
Strontium oxide. Yeah, that's a great one. SRO. Okay? And that actually, when it's formed, produces a bright red light. It's kind of neat. Yeah, Miss Lalonde.
SRSE.
SRSE. Yes. Okay, that would be a good one. Gloria.
NABR.
NABR, sodium bromide. Yeah, that's a good one. Okay, what else? Does anyone have one that's not up here? Emma.
K2 plus SE.
Ah, okay, K2. So then we want, it would combine with the following.
Plus selenium.
Oh, SE.
Yeah.
Okay, yes. That would work. All right, so we have another double, which is really good. Yeah. KBr, potassium bromide. And I believe we have potassium iodide, we have potassium chloride, but we do not have a potassium bromide. We have a francium iodide, but we're going to go with KBr. Yeah, that's a good one.
How many we have?
We have 5, 10, 15, 20, 25, 26.
Oh, 26. We're close. Grace, you have one that we don't have?
SECA.
Okay, SECA. We have to flip those around.
CASE.
CASE, and we have that one right here.
Oh, well,
Okay.
that's why I was confused.
Wait, Mr.
Yes.
RB4 plus C.
RB4C. Yeah, you could potentially make that one work. So it would be RB4, gives us 4 valence electrons, and then you tack a carbon on the end, and that would give us 4, and that's 8. So yeah, that's probably one of the trickiest ones I've seen today. Yeah.
NaCl.
Na, table salt. Yeah.
Yummy.
You're
NaCl.
welcome.
Yeah, table salt. Okay, any others? Any others that you do not have? I'm going to collect these, make sure. BESE.
This.
We have base.
I don't think so. BESE would be a good one. Yeah.
It's me again.
Okay. Yeah, Ariana.
RBI.
RBI. Runs batted in.
That's
Fantastic. And RBI would work, and it's not up here, so.
Rubidium iodide.
Yes, Ariana.
RAS.
RAS. No, we don't have that one yet. That's a good one too. Radium sulfide. Radium is actually can be radioactive. They used to use it in clocks, German clocks more specifically. Yeah. HBr. That I'm glad you bring that up again. H is a nonmetal. You cannot use that. That is a neat substance though. We'll get to it at the end of the semester. Yeah. C. No. Which one is it? CS. CI. Cl. Yeah. Cesium chloride. I don't think I've written that one down. I think I would have remembered it. So CS, Cl. Yeah, that is one. I think it's Cl. I think it looks like an I, but it should be chlorine. This one would work. Probably is chlorine.
We have 30.
Did we hit 30?
thought we had
We're getting
32.
close. Grace?
No, we have 30 right now.
FR.
No,
3.
there's 5.
SE.
FR.
5 times 6.
Wait, FR. 3.
1, 2, 3,
N.
4.
Okay, FR3N. Yes, FR3N
It's 30.
would have worked. Yes.
No, you have 30.
Okay.
You have 33.
Yeah, he's 2.
Does anyone have one that's not up here,
I have one that could be like combined.
but is it on your sheet?
No, but it's
Okay, hang on. Let's make sure we get everyone that has one on the sheet. You have 5 check marks or a few notations. Everyone have?
Tell how many are there and then do the math and see if everyone
Mr.
did it.
Well, but some people would have gotten.
Oh,
Some people might have the same one. Yeah.
FR3 plus P.
FR3P would work. FR3P, francium phosphide. Okay.
Is that radioactive? There's 31, but you have 2 repeated.
Ah, I do have a couple of repeaters. Yes. Rubidium chloride is a repeater. And
We have
calcium.
MGS was.
MGS was a repeater. Oh yeah, right here.
So we have 31. I have
So we're just a little short. Wait, we hit
we have
about 30.
31. We have 31.
Thank
I
you.
counted.
Very good. These are ionic substances. Ionic. Because they have 8 valence electrons total and they have a metal-non-metal combination. Now, today's lesson, I'll collect these from you in just one moment. Today's lesson deals with covalent bonds. I'm going to tell you covalent bonds have fewer rules. Okay? As a matter of fact, they only have one rule I want you to be aware of for this particular unit. I am going to go ahead and leave these up, but I'm going to erase this over here. Okay. Just so you know, many of these substances are in day-to-day foods. Many of them you can buy at the grocery store, like for instance, potassium iodide, okay, is a medicine. A couple of other of these things, like lithium chloride, is a salt.
What kind of potassium is in bananas?
Probably potassium chloride is in bananas.
You said one of
I'm not
them
eating
makes,
bananas.
like a weird red light.
Yeah, anything with strontium is probably going to have, so if it's burned, is probably going to give off a really cool red light. Okay? So these have unique characteristics. However, there are substances that you are familiar with that don't fit this. Does anyone know what substance covers over 70% of the surface of the Earth?
Water.
And what is the chemical compound for water?
H2O.
Jackson.
No.
Can we write this?
Yes.
Okay.
Okay, Parker, before you write it. Parker, hydrogen, right here. Metal or non-metal?
Nine.
Very good, it's non-metal. Oxygen, metal or non-metal?
What's that mean in a metal? I know.
It's the ultimate metal.
So here's,
It is a metal.
no, it's not. You were right. Is there a metal here?
No.
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 But yet, water is incredibly abundant
Isn't there iron in it?
Really?
in water.
Well, isn't there like no?
Oh, there's rust.
Oh, I see what you're saying.
Like, 'cause
In
water's
well
far
water,
away.
you might have like lots of iron.
Yeah.
It's not part of the chemical. It's dissolved, like salt water. If you let it evaporate, it leaves the salt behind. It's the same idea with iron and water. It just floats in there. It's not a part of it.
Well, isn't it like make sinks like red or something?
It does. It makes sinks, toilets,
You can
bathtubs
take
red.
it out.
Like
Yeah.
that sand, they have red sand at the zoo and the
Yep,
app.
and it's
Australia.
rich in iron. Sure. Does anyone know anything else, any other substances that don't have metals that we're familiar with? They're really common. Think about it for a moment. What kind of substances were you familiar with before you came to class, this year, that you'd heard?
Lithium fluoride.
Yeah,
Salt.
okay. Salt. Salt is over here. The salt we're familiar with is right here. I'm thinking of substances that might have to do with plants. Okay.
I've heard of CO2.
Okay, oxygen. Oxygen is actually called O2. That's a possible substance that falls in this category. Yeah.
Soil.
Okay, not soil. Think about gases. Think about things floating around. Yeah.
Oh!
Carbon dioxide. Like so. How many of you have ever seen this sugar or heard of sugar, C6H12O6?
Oh yeah.
They talked about it in the Bill Nye video.
A sugar.
Are any of these metals, Bo Behrman? No.
They're minerals. Right?
Covalent substances. Hang on. Covalent substances. What is the biggest difference between an ionic substance and a covalent substance besides the fact that these electrons are shared and those are taken? What is the biggest difference here? What is the biggest difference between this massive list that we made and these substances here? What is the difference? Caleb?
There's no metal.
That's
on the
it.
left side.
There's no metals. Star it, underline it.
So covalent bond has no metal.
If you have a substance that is covalently bonded, it will not have metal. It will be made of only nonmetals. These substances are a huge quantity of what's the Earth's atmosphere. The Earth's atmosphere is all covalent. Water covers 70% of the globe. It's covalent. Okay? This is a huge portion of what our Earth is made out of. Okay? Stars are made out of substances that start out covalent. Okay? Covalent bonds. Parker.
So okay, again back to the water. So when the iron comes in, does the iron ever like change the substance of the water?
Nope.
Like does
It just floats around, and then when the water...
all water is H2O, right?
Yes.
Every little thing of it.
Yes.
But when the iron comes in, wouldn't that mess up the H2O?
No, it doesn't. Think about it like this, Parker. Let's say you have a big bowl of marshmallows. Okay? Most people do love marshmallows. So you have a big bowl of marshmallows. And I come along, and I dump Cheerios into your bowl of marshmallows. Okay? And I mix it all up. No, listen very carefully. Because Parker's... Hey, guys. Parker's question is a fantastic one. Okay? Do the marshmallows change from marshmallows?
No.
No. But are there Cheerios in the bowl with the marshmallows?
Yeah.
Could I remove the Cheerios? If I picked them out one at a time?
But when you
Eventually.
see iron coming out of the water, you don't see chunks of iron coming out of the fountain.
You kind of do though, don't you? You see the red stain. That's all of the iron that's settled out of the water.
The pieces of iron are big.
No, they're atoms of iron. You're right. It's just a much smaller version of the same thing. Okay?
I think I get it.
I think you do. I think you do. You asked a very good question. That's probably one of the best questions I've had today. Okay?
Oh, I need to think of a question.
Oh, this is the very best question.
One
of
up
all
there.
time.
Well, hang on 1 second, Caleb. Before we get too far, because we have reading time coming up here. Ladies and gentlemen, what if I were to give you a quiz question, which I will Wednesday, and I were to ask you to identify a covalent substance or an ionic substance just by giving you its formula, which is what we call these. What would you look for? Gloria.
I want to see if there's two metals, or if there's a metal and a non-metal, or if it's just, if it doesn't have a metal.
Right. You're right.
Mostly.
If it has a metal, it's going to be what? Which one? Ionic. If it doesn't have a metal, it's going to be covalent. Now, let's say that I were asked you to make an ionic substance on a test. Give me an example of one or identify one. You have to make sure that the electrons add up to what number? 8. 8.